Hey guys, this is Abhishek and you're watching my channel One Day Batting. In this video, I'm going to explain you the solutions of level 1 questions of de Moivre's theorem. And here is the list. We have 4 level 1 questions and I considered these questions as level 1 because these questions appeared in IPE examinations of various boards frequently. So I considered these questions as level 1 and let's see the solutions to these problems. Okay guys, this is the first question of level 1 and in order to find these kind of problems we have to do two steps. First we have to write mod amplitude form or trigonometric form or polar form of this 1 plus I and 1 minus I. After simplification, we have to apply de Moivre's theorem to get final RHS. So let's do. In order to find polar form of 1 plus I, we have a formula. That is 1 plus I equals to R of cos theta plus I sin theta. To find R and theta we have formulas and let's see them. R is equals to under root a square plus b square. To know this a and b value we have to compare this 1 plus I with general form of complex number and let's do this quickly. 1 plus I is equals to a plus ib. Here a is equals to 1 because here constant we have a and b is equals to also 1 because there is no term here. So we got a as 1 and b also as 1 and I am substituting these a values here. Under root 1 square plus 1 square which is equals to root 2. Therefore we got R value. Now to find theta we have another formula, that is tan inverse of b by a. As we have b value and a value, so I am substituting these values over here. Then we get tan inverse of 1 by 1 and then we get tan inverse of 1. We can write tan pi by 4 because tan pi by 4 value is 1 and here tan inverse tan is get cancels and finally we get theta as pi by 4. So finally we got R value and theta value. So you have to substitute these two values over here to find the polar form of 1 plus I. Okay guys, I'm rubbing this. Okay guys, I am substituting R equals to root 2 and theta equals to pi by 4 over here. So that we get root 2 times cos pi by 4 plus I sin pi by 4. Similarly, 1 minus I, complex conjugate of this complex number. We get root 2 times cos pi by 4 minus I sin pi by 4. So we got 1 plus I and 1 minus I polar forms. So we have to substitute these two values over here. So in order to do that we have to consider LHS part. Consider LHS part. 1 plus I whole power 2n plus 1 minus I whole power 2n. So root 2 times cos pi by 4 plus I sin pi by 4 whole power 2n plus root 2 times cos pi by 4 minus I sin pi by 4 whole power 2n. So in this step we have to apply de Moivre's theorem. So after applying we get root 2 whole power 2n cos 2n pi by 4 plus I sin 2n pi by 4 plus root 2 whole power 2n cos 2n pi by 4 minus I sin 2n pi by 4. So I am taking root 2 whole power 2n as common. So after taking that we get root 2 whole power 2n of cos 2n pi by 4 plus I sin 2n pi by 4 plus cos 2n pi by 4 minus I sin 2n pi by 4. So guys, here plus I sin 2n pi by 4 and minus I sin 2n pi by 4 gets cancels. So finally we get root 2 whole power 2n times 2 cos 2n pi by 4. Now okay guys, I am writing this last step over here again, that is root 2 whole power 2n of 2 cos 2n pi by 4. Here 2 1s, 2 2s, and root 2 can be written as 2 power 2n by 2. Here 2 1s, 2 1s, 2 cos n pi by 2, and here 2 power n times 2 cos n pi by 2. Here bases are equal, then power should be added, as you already know this very well. So 2 power n plus 1 cos n pi by 2, which is equals to RHS. So therefore LHS equals to RHS. Hence proved. And this is a solution for first question. And let's move on to the second one. See, we have, okay guys, and this is the second problem of level 1 questions. This is similar to the first question, so we have to use the process which we used to find the first question. So let's do this quickly. To find that, we have to write the polar form of 1 plus I, right? 1 plus I is equals to r cos theta plus I sin theta. So we have R equals to a square plus b square. To know a and b values, we have to compare with a plus I, b, and a is equals to 1 and b is equals to 1. So under root 1 square plus 1 square, which is equals to root 2. And theta is equals to tan inverse of b by a, and tan inverse of b value 1 and a value is also 1. So tan inverse of tan pi by 4, the value of tan pi by 4 is equals to 1. So I am replacing this 1 as tan pi by 4. So here tan inverse tan gets cancelled and theta value we get pi by 4. So we have to substitute this R and theta value over here. So 1 plus I is equals to root 2 times cos pi by 4 plus I sin pi by 4. So complex conjugate of 1 plus I is 1 minus I, right? So to write this, root 2 times cos pi by 4 minus I sin pi by 4. So we have to substitute 1 plus I, 1 minus I polar forms over here. So to do that, we have to consider LHS part. LHS equals to 1 plus I whole power n plus 1 minus I whole power n. So let's do this quickly. Root 2 times cos pi by 4 plus I sin pi by 4 plus whole power n, and root 2 times cos pi by 4 minus I sin pi by 4 whole power n. So in this step we have to apply de Moivre's theorem. Root 2 whole power n. After applying, we get cos n pi by 4 plus I sin n pi by 4 plus root 2 whole power n times cos n pi by 4 minus I sin n pi by 4. So I am taking root 2 whole power n common. Then we get root 2 whole power n of cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n pi by 4. Here plus I sin n pi by 4 and minus I sin n pi by 4 gets cancelled. So finally we get root 2 whole power n 2 cos n pi by 4. So root 2 can be written as 2 whole power n by 2 times 2 cos n pi by 4. So I am writing this last step over here again. That is 2 power n by 2 times 2 cos n pi by 4, right? Here bases are equal, then power should be added, right? So 2 power n by 2 plus 1 cos n pi by 4. So we get 2 plus 2 by 2. Here 2 goes over here. Cos n pi by 4. This is equals to RHS. So finally LHS equals to RHS. Hence we proved. That's all. Now coming to the third one. Okay guys, third problem. In order to solve this problem, we have to do three things, right? First, we have to find the roots of this quadratic equation, and then after finding the roots, we have to find the polar form of those roots, and after simplification we have to apply de Moivre's theorem. Then we get this RHS part, and let's do. First, I am considering this quadratic equation: x square minus 2x plus 4 equals to 0. To find the roots of any quadratic equation, we have a formula which you already know, that is minus b plus or minus under root b square minus 4ac by 2a. Here the roots given in the problem are alpha comma beta, so I am writing alpha comma beta on left hand side. So to know this a, b, c values, we have to compare this quadratic equation. Let's consider this equation as 1. So to know the values of a comma b comma c, we have to compare this equation 1 with the general form of quadratic equation, that is ax square plus bx plus c equals to 0. So we have a value as 1 here because the coefficient of x square is 1. So a equals to 1, and similarly b equals to minus 2, and c is equals to 4. So substituting these a comma b comma c values over here, we get alpha comma beta. So let's do this. Minus of minus 2 plus or minus under root b square, that is minus 2 whole power 2, 4 of a value 1 and c value 4 by 2 of 1. We get minus into minus plus, so 2 plus or minus under root 4 minus 16 by 2. So 16 minus 4, 12, that is minus 12, right? Under root minus 12. Here, see guys, as you already know, I square equals to minus 1. So we can replace this minus 1 as I square. So I am replacing here 2 plus or minus under root minus 1 whole square, plus I whole square of 12. So okay guys, after solving this step, we get 2 plus or minus I under root 12 by 2. Here root 12 can be written as 2 plus or minus I 2 root 3 by 2. I am taking 2 common. So 2 of 1 plus or minus root 3 by 2. Here 2 gets cancels. Finally we get 1 plus or minus I root 3. Okay guys, we got alpha comma beta equals to 1 plus or minus I root 3. So therefore alpha equals to 1 plus root I3 and beta is equals to 1 minus I root 3. Therefore we got roots of this quadratic equation. So I am substituting these values in LHS part. So consider LHS part. LHS equals to alpha whole power n plus beta whole power n, right? And we got alpha value 1 plus I root 3 whole power n and beta value 1 minus I root 3 whole power n. And we have to write the polar form of 1 plus I root 3 and 1 minus I root 3. And the polar form of 1 plus I root 3 is 1 plus I root 3 equals to r of cos theta plus I sin theta, right? So in order to find r, we have a formula, right? R is equals to under root a square plus b square, and we have to compare this 1 plus I root 3 with general form. So that is 1 plus I root 3 is equals to a plus ib, right? And a is equals to 1 and b is equals to root 3. And I am substituting these values over here. So we get 1 square plus root 3 whole square, which is equals to root 4, and root 4 means 2. Therefore we got r value as 2. So let's find theta. Theta is equals to tan inverse of b by a, and we have b as root 3 and a as 1. So I am substituting over there. So tan inverse of root 3 by 1, that is tan inverse of root 3. We have tan pi by 3 is equals to root 3. So we can substitute root 3 as tan pi by 3. So we get tan inverse of tan pi by 3, right? So here tan inverse and tan gets cancelled. So finally we get theta value as pi by 3. So we have to substitute r value and theta value over here, so that we get polar form of 1 plus I root 3. Okay guys, I am substituting r equals to 2 and theta equals to pi by 3 over here, so that we get 2 of cos pi by 3 plus I sin pi by 3, right? And similarly 1 minus I root 3, which is the complex conjugate of 1 plus I root 3. I root 3 whole power n is equals to 2 of cos pi by 3 minus I sin pi by 3. So I am substituting this 1 plus I root 3 whole power a small mistake. I am substituting 1 plus I root 3 and 1 minus I root 3 values over here. Therefore, we get 2 of cos pi by 3 plus I sin pi by 3 whole power n. Here we have n, right? And plus 2 of cos pi by 3 minus I sin pi by 3 whole power n. So in this step we have to apply de Moivre's theorem, right? And after applying de Moivre's theorem, we get cos n pi by 3 plus I sin n pi by 3. Similar way, 2 power n of cos n pi by 3 minus I sin n pi by 3. I am taking 2 power n common. So we get 2 power n of cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3 minus I sin n pi by 3. So here plus I sin n pi by 3 and minus I sin n pi by 3 gets cancelled. So finally we get 2 power n times 2 cos n pi by 3. Here bases are equal, then power should be added, right? So 2 power n plus 1 times cos n pi by 3. So which is equals to RHS, right? So therefore LHS equals to RHS. So hence we proved. Yeah. Now coming to fourth one. This is the last question of level 1. Okay guys, to solve this problem, first we have to solve this 1 plus I cos theta plus I sin theta and this 1 plus cos theta minus I sin theta, and then writing that in polar form and applying de Moivre's theorem. Then we get this RHS part. So let me consider this one, 1 plus cos theta plus I sin theta. So according to trigonometric formulas, we have 1 plus cos theta as 2 cos square theta by 2 plus this sin theta as 2 sin theta by 2 cos theta by 2, right? So I am taking 2 cos theta by 2 as common. So 2 cos theta by 2, then we get cos theta by 2 plus I sin theta by 2, right? So similarly this one, we can write that as 1 plus cos theta plus minus I sin theta equals to 2 cos theta by 2 of cos theta by 2 minus I sin theta by 2. So we have to substitute this 1 plus cos theta plus I sin theta and 1 plus cos theta minus I sin theta values are here, that is LHS part. So to do that we have to consider LHS part, right? So I am considering LHS part, this one. So we can write that as 2 cos theta by 2 of cos theta by 2 plus I sin theta by 2 plus 2 cos theta by 2 of cos theta by 2 minus I sin theta by 2. So I am taking 2 cos theta by 2 common from these two elements. So we get 2 cos, we have whole power n, n here, and here also we have n. So in this part we have to apply de Moivre's theorem, right? So after applying de Moivre's theorem we get like this: 2 power n cos power n theta by 2, and we get cos n theta by 2 plus I sin n theta by 2 plus cos n theta by 2 minus I sin n theta by 2. So see carefully, we have plus I sin n theta by 2 and minus I sin n theta by 2. So these two get cancelled. Finally we get 2 power n cos power n of theta by 2. Here we have cos n theta by 2 and cos n theta by 2. So we can write 2 cos of n theta by 2. Here 2 power n and 2 power 1. So here bases are equal, then power should be added. So we can write 2 power n plus 1 cos power n theta by 2 cos n theta by 2. So this is equals to RHS, right? Which is equals to RHS. So therefore, we got LHS equals to RHS. So hence proved. So just remember, you have to write this last step also, because to get maximum marks you have to write this at any cost. So this is a solution for fourth one. Yeah, that's all guys. Thank you for watching, and don't forget to subscribe to my channel and tap on bell icon to get all notifications. Have a great day guys.